This is the brief on the tensor form of the centrifugal force. Okay, so in physics, calculating that centrifugal force, it usually means wrestling with this kind of messy vector triple product, right? It's a lot. But turns out there's a much cleaner way. This source material confirms we can actually define that force with a simpler, linear relationship using something called a tensor. Think of it like a specialized matrix. So why does this matter? Well, it really tidies up our understanding of rotation physics. Let's jump into the 3 key things you should know. First, we ditch that complicated vector calculation for a nice linear one. The big idea here is that the force, Fci equals Tijxj, is shown to depend directly and linearly on the particle's position vector, vec(x). It's all laid out cleanly by this tensor, T. Much simpler, right? Second, what is this centrifugal tensor, T? Well, its components, Tij, are symmetric, which is neat. Tij equals Tji. And critically, they depend quadratically, squared, on the mass, m, and the angular velocity, vec omega. So spin something just a bit faster, that force jumps up way more because of that squared relationship. Finally, this whole tensor setup tells us exactly when the centrifugal force just vanishes. It happens only if the particle's position, vec(x), is perfectly lined up, parallel, with the angular velocity vector, vec omega. Basically, the particle has to sit right on the axis of rotation. Anywhere else, you feel the force. So, yeah, this verification gives us this really concise, symmetric tensor framework, turning a messy vector problem into a much more elegant, linear way to handle rotational dynamics.